You know, the ground beneath our feet feels so solid, right? So permanent, unshakable. But what if I told you that's all an illusion? That the very continents we live on are adrift, floating on a sea of molten rock, constantly rearranging the face of our planet. Today, we're going to dive into the incredible story how we figured out our world is in constant slow-motion movement.
So it all starts with a really simple observation, one you've probably made yourself just by looking at a world map. Have you ever noticed how the continents, especially South America and Africa, look like they could just click together? This simple question baffled scientists for centuries, and it set the stage for one of the biggest revolutions in how we see our own planet.
And this wasn't just a casual thought. It was the first major clue that our world map hasn't always looked the way it does today. Let's take a closer look at the most famous piece of this giant puzzle.
I mean, the connection is just undeniable. Look at that prominent curve of eastern South America and see how it nestles almost perfectly into that big indentation on the west coast of Africa. This is a poster child for the continental fit, a powerful geographical hint that these two huge landmasses were, at some point, joined together.
Now, an observation this huge needed a champion, someone willing to propose a truly wild, revolutionary theory to explain it. And that champion was a visionary scientist named Alfred Wegener.
So, back in 1912, this German meteorologist and all-around adventurer Alfred Wegener puts forward this comprehensive theory he called continental drift. He actually argued that the continents weren't fixed in place, but were literally plowing through the Earth's crust over millions of years, kind of like giant icebreakers on a frozen sea.
And the centerpiece of his whole theory was this idea, Pangaea. He said that way back about 300 million years ago, all the land on Earth was fused together into one enormous supercontinent. Every place we know today, North America, Asia, Australia, it was all part of this one single landmass before it started to break apart.
And Wegener didn't just rely on the map. Oh no, he brought some serious evidence from all different fields of science. He pointed to identical fossils of land-based animals and plants found on both South America and Africa, continents now separated by thousands of miles of ocean. And get this, he also showed how rock formations and even entire mountain ranges, like the Appalachians in North America, were a perfect match for mountains over in Scotland. They were once part of the same continuous chain.
But here's the crazy part. Despite all this powerful evidence, Wegener's theory was widely rejected for decades. Why? Because it had one massive, glaring, unanswered question right at its heart.
This was the big problem. Wegener had the what, but he couldn't explain the how. He was right that the continents were moving, but had no idea what the mechanism was. I mean, what kind of engine is powerful enough to push an entire continent across the planet? Without an answer to that, the scientific community just kind of dismissed his brilliant idea as fantasy.
Well, the answer and Wegener's ultimate vindication would have to wait for decades. It took new technology that finally allowed us to explore the ocean floor, and this led to the modern, complete theory we have today. And here it is, the missing piece of the puzzle, plate tectonics. We now know the Earth's surface isn't one solid piece. It's actually broken up into these enormous plates, almost like a cracked eggshell. And these plates, they're floating on a hot, semi-fluked layer called the mantle. You can think of it like a giant conveyor belt, where intense heat from the Earth's core creates these slow-moving currents that just carry the continents along for the ride.
Okay, so this is a really important distinction to make. Wegener's continental drift was the groundbreaking observation. That was the what. Plate tectonics is the mechanism. That's the how. It provides that powerful engine that Wegener was missing, finally completing the incredible picture he started drawing way back in 1912.
So, this isn't just ancient history. This process is happening right now, as we speak, constantly reshaping our world in ways that are both super subtle and incredibly dramatic. The speed is incredibly slow. We're talking about the same rate your fingernails grow, just a few centimeters a year. But when you multiply that tiny distance by millions and millions of years, you end up with vast oceans and towering mountain ranges. It's a perfect example of how small, steady changes can lead to absolutely massive results over time.
And this movement generally happens in three main ways. Plates can pull apart, which lets magma rise up and create new crust. That's how oceans form and get wider. They can collide head-on, buckling and pushing up the land to create colossal mountain ranges like the Himalayas. Or they can slide past each other, grinding along fault lines and building up tension that eventually gets released as a powerful earthquake.
And just to put this into a real-world, right-now context, the Atlantic Ocean is actively getting wider as we speak. Europe and North America are moving away from each other year after year. The same forces that broke up Pangaea are still hard at work, rearranging the face of our planet.
So ultimately, the single most important takeaway from all this is just how dynamic our planet is. It's not some fixed, solid ball of rock. It is a living, breathing system with a churning, hot interior that constantly reshapes the surface. It's a great reminder that the ground beneath our feet is never truly still.
And that brings us to a final, pretty fascinating thought. If the continents have drifted this much in the past, they're going to keep drifting into the future. In fact, scientists predict a new supercontinent might form one day. So the question isn't just what the Earth looked like, but what will it become?